What's up, everyone? This is Ryan here, and we are live for episode 21 of my live stream Q&A. So I didn't do an episode last week because I had the flu, and unfortunately, I am feeling much better, but I still have a little bit of congestion going on. So you guys and girls are unfortunately gonna have to bear with me sniffling and clearing my throat and a whole bunch of stuff like that. But we're gonna carry on regardless. Also, like 2 minutes ago, the clip for my microphone broke, so this thing's going to be just kind of hanging out here. Hopefully the sound is still okay. So let's kind of get started here. All right. So today's episode, it's going to be a pretty standard Q&A. I do have one sort of pre-set up viewer question, which I'll be answering, but beyond that, it's just going to be pretty much rapid fire answer as many questions as possible. But before we get to that, of course, I'd just like to thank the following people who have chosen to support me on Patreon. So that's Seth Keegan, Shan, Tina Fredericks, Tony Jones Jr., Trevor Halvorson, Bassam Halal, Nanotech, Shadow, Mr. Bidwell, Sushil Chanda, and Elad Stavmy. So to all those people, thank you very much for supporting me. It's much appreciated. And that is the commercial for the day. I don't have too much in the way of announcements, really just one thing. I basically spent September writing an ebook for Android, introductory ebook, and that's pretty much what I spent all my free time doing. So it's very close to done, and I think it's going to be a really good sort of overview of not just how to build Android apps, but like how to design them. And what I do in the book is I sort of lay out my whole design process and explain sort of the stuff that I feel gets left out. So there are a fair number of code samples, but it's not so much about having an expansive sort of suite of code samples to show you how to implement things, but it's more how do you actually design an app? What are the parts of it? How should you divide the responsibilities? That kind of thing. So I should be able to announce an official release date next stream, which will be, of course, next Sunday. So that's basically it for our announcements. And what's up? We got I joining us and Linksy. Yeah, I can certainly help you with that. That's yeah, that is an older project. Links. I've got a viewer asking if I can overview my profiler chat app, and which it doesn't actually have chat integrated yet, but I can certainly talk about it. And yeah, all right. So before we do that, I just have a question which I was going to answer last stream, but I totally got sick. So we're going to deal with that first. And so where are we here? Of course, I deleted the question. Here we are. And this question is from Renat. Renat. Where are we? All right. So the question is, this is from Renat, asked a little while ago. Hi Ryan, I had a look at your PosTrainer repository a couple of days ago, and I noticed that all that use cases, aka interactors, do is that they just delegate their work to the underlying implementation of the repository. Thus, the logic of displaying is implemented in presenters, and the logic of fetching and syncing data is implemented in the repository. So my question is, why do we need use cases if all they do is just delegate that work? I don't understand their role in clean architecture. So this is a really awesome question. Now, it does require a little bit of an understanding of clean architecture, and that is sort of the general question here. Now, unfortunately for the beginners watching, normally what I do is I would sort of overview clean architecture, but I'm really going to try and answer just a large number of questions today, so we're not really going to do that. But if you're curious, I do have content on clean architecture and lots of past Q&As where I talk about it. But let's just kind of get in here. I will very briefly talk about it or overview it. So one of my main repositories is PosTrainer. It's down in the description box. And it's basically, for the time being, it's sort of modeled after clean architecture. Now, I do have lots of changes that I need to make, and that's part of the answer to this question. But just really, really briefly, the application uses model view presenter architecture for the front end. So let's say I go to alarm list feature, and there you're going to find a fragment, which is the view, and I inject a presenter into that fragment. The presenter is the presenter, and this presenter, if I zoom in here, it's full of these things called use cases or interactors. And that is where sort of the clean architecture stuff comes in. So if you weren't using clean architecture, probably how this would work is within the alarm list presenter, it would be depending, or it would have as a member variable, I don't know, whatever. It would have as a variable a repository object, and it would be talking to that. Whereas in clean architecture, your sort of model view presenter, which you can think of as the, usually it's called the presentation layer, it talks to a different layer, which is the use case layer, or interactors, they're sometimes called. I think Uncle Bob calls them interactors. Anyways, I'm rambling. So what I do is, instead of having this presenter, any of my presenters depending directly on data sources or databases, like here we've got alarm source, which is basically just a database. It's a realm database in this instance, but because we want to abstract our code, I'm not even hinting that it's a realm database. I'm just saying this is where you can get alarms from. And then we also have this alarm manager, which is basically full of the services necessary to wake the device and stuff like that, system services. So what I do is I inject these things into the presenter, and I create my use cases with each service that they require. And so this way our presenter is depending on these use cases, and it's sort of decoupled from our data layer quite well. So, and the use cases themselves, I'll just briefly show you really quickly. So this is, for example, a use case. They're quite, they basically implement a interface, and all that really does is they'll generally just contain a method called run use case, and that will ask the service for whatever it needs. So essentially what Renata's saying is, okay, so I see you've got this use case thing, and all this use case thing really does is it's just like a buffer layer that tells the alarm manager dismiss alarm. So that, you know, that doesn't really seem like it's particularly useful. So I'll kind of explain a couple of things about this. Why do I have all of these open? So here's the thing. There's a couple points I wanted to make. Now, I don't have an amazing answer here, but let's do, let's see what we can get to. All right. Okay. Sorry, just messing around with my notes here. So there's a couple of things that I wanted to discuss, really just two, and I'll try and make this useful. So number one, so the first thing is that use cases, and so what I'm going to be doing is I'm going to be sharing with you my experience and my knowledge of them, which is admittedly not complete. I have built a couple apps in this style, but I don't, you know, I'm an intermediate Java developer. I don't have 10 years of experience building systems like this. But here's my understanding and how I apply clean architecture and use cases. So the first thing is use cases, excuse me, use cases are a big part of my design process. So sort of the more abstract thing I wanted to say about them. So when I think of a use case, really what I'm thinking of is it's a series of steps towards a single sort of goal. So for example, let's say I open up my Pos Trainer application on this phone and I toggle an alarm. So that's going to do two things. Sorry, I'm going to be sniffling and stuff. That's going to do two things. So number one, it's going to tell my services to either set the alarm or to cancel it, but it's also going to have to write that alarm to a database so that the data is consistent with that. So those are basically two steps toward one single use case or one single goal. So that's what I think of as a use case. It's a series of steps toward a single goal. Now, that's the first thing that I wanted to mention here. So let's just go back. So yeah, number one. Oh, this thing's annoying today. Okay. So number one, it's sort of like a goal. Hopefully that explains what a use case is anyways. So when I'm designing an app, basically what I'll do is after I look at the problem domain and I figure out what data I need, which for Pos Trainer the data is alarms, the next part of my design process will be to actually look at all the use cases. So what are the things my app needs to do? So I'm going to write them out, like save alarms, set alarms, delete alarms, configure alarms, all that crap. All those sort of single operations I will write out as use cases, and that actually helps me to design the application. It helps me to figure out, okay, what does my app what should it be expected to do? And it helps me to start thinking, where am I going to, okay, I need to be able to delete apps. Should I do that here? I need to be able to create an alarm, but also edit them. So I could probably have those two use cases fundamentally doing the same thing, that kind of stuff. So anyways, so that's the first thing. They help with my design process. Now, the next thing that I wanted to mention is that as far as this project in Pos Trainer, it's not actually totally complete. So the example I wanted to give you is, and this is something I will be working on soon, but let's look at, which one am I on? Alarm list presenter, yeah. So let's look at the alarm toggled method. So if I pull up Pos Trainer really quickly here, one sec. Okay, so if I pull up Pos Trainer, the use case that I'll be looking at is called onAlarmToggled, and all that happens is you've got a list of alarms here, and it's hard for me to do it, but there's a little switch. I can press the switch. Oh, maybe I can't. Oh, come on, you bastard. There we go. Okay, and it says alarm activated. So all I did was just hit that little switch there to turn the alarm on. So I toggled an alarm. I'm going to untoggle that so it doesn't go off. Okay, and that corresponds to the following use case, the following method, onAlarmToggled. So essentially the use case itself I would think of as either activating or deactivating an alarm. Now the way that I handle this in code is that I execute update or create alarm, the update or create alarm use case. What this use case does is it just writes the alarm to the database. After that, after I get a response from the use case, it returns the observable. I call a second method, and I either tell the services to set the alarm or to cancel the alarm. And then what ends up happening is another use case gets executed. So why am I like babbling about use case, use case, use case? What I would actually like to do, and I think where part of the utility of these use cases is that I don't think this is optimal. What I would rather do is sort of wrap all of these operations into a single use case that has both the database and the alarm service in it. And then that use case would worry about whether the alarm needs to be written, whether it needs to be canceled, or anything like that. And all my presenter should really worry about is just calling the use case and sending it the data. Whereas in this case, I've put a fair amount of logic into the presenter, which is something I don't really want to do. So what I'm trying to get at here is that I think if you use cases, if you use use cases in a more efficient way than I have in this project at the moment, you can offload a lot of that logic into the use cases themselves, and that would drastically simplify the code in my presenter. So what I'm trying to say, Renat, is my implementation is not quite complete. Use cases are a lot more than just delegating the whatever the code or the data to code and data to execute the call on the repository. I can't finish my sentences. It looks that way in my project because it's not totally optimized, and I totally understand why you might think that. But later on, I'll try and add some stuff to POS Trainer, and hopefully that will clear things up a little bit. So anyways, I'm just going to mute myself and run a quick commercial break while I blow my nose. One moment, please. Oh yeah, that's good. All right. So, yeah, so that was use cases and Renat's questions. So hopefully that clears a couple things up. I know it's not a great answer, but hopefully I at least was able to share some of my understanding. Joshua, I can possibly answer your question later on. Interesting. That's okay. We got a couple of good questions. Let me just sort through here for a moment. So, Firebase bonfire chat up. You know what? Honestly, Linksy, if you're still there, so that application is pretty old. I'll go over the package structure really quickly, but it's not necessarily optimal. So I'll pull it up, and this is just going to be a quick, just kind of a quick question, because I don't even really like people looking at this code at the moment because it's so bloody old. But wow, I totally didn't finish that thought at all. Okay, so how does the package structure of Profiler work? And Profiler is one of my repositories. Now this is the oldest kind of repository I reference at all, and it was made like 8 months ago or something like that. So there's a lot of stuff in here that I'm not really, that is not great because it's old. But anyways, let's just have a quick look at here. So the question was like, can I sort of overview the package structure and how this thing works? So it's pretty simple. We've got, I suspect what Linksy is most curious about is this mock and prod stuff. So how this repository basically works, and this was my first sort of attempt at doing a package by component and layer. So there's two main camps for structuring the packages of your application. So some people like to do it by layer. So they'll pick an architecture like model view controller or model view presenter, and then what they'll do is they'll say those will be like main packages in their application. And some people like to package by feature or package by component, sometimes it's called. Everyone likes to use different names for everything. And so basically what that is let's say you have like a single sort of screen of your app. So for example, I've got, this would be alarm list, that thing I showed you earlier. That would be a feature of the app. And if I go to edit that alarm, it would open up the creator edit alarm feature. I think it's alarm detail feature. And you can make a package for each of those features. So that's another way to structure your packages. I actually do both. I put feature level code into feature packages, and then I put more global sort of by layer type code into their own packages as well. So for example, within Profiler, you'll see that I have the photo detail, photo gallery. These are all single features of the app. And then I have like data, which represents all the different sort of, if you're doing like model view controller, that would sort of be like the model. Everything responsible for storing data pretty much, and stuff like that. So that's sort of the general architecture there. Now, probably what you're curious about, and I could be wrong here, is if I go back to the source package, there is a mock and a production source set, is what this is called. And so basically how that works, and again, this is not the most optimal implementation of this, but so basically if I can't open up the project itself right now just because my computer would lag like crazy, but let's just look at the build.gradle. So what I've done is I've gone into the build.gradle file and I've added two product flavors, mock and prod. So that stands for mock and production. So when I want to test the application within, if I open up POS Trainer here and I go to build variants, the build variants tab, you'll see that I can switch between build variants. So I could go to mock, prod, or debug, or prod release, and I can switch those at will. And basically how that works is when I want to test the application, I will switch to mock, and when I want to run the application on like a device and actually test the real thing, I will switch it to prod or production. And so how that kind of works is when you switch all this, there's no magic here. When you switch the build variant, what happens is, it just swaps this source set out for the other source set. So the last thing I'll kind of say is if I go to mock and then database, you'll see it says fake database service. And if I look at that, it's just like a fake class that supplies canned data pretty much. Whereas if I go to the prod source set, it will be a real database, which in this case is a Firebase database service. And this is a real class. So that's really all that's going on there. Hopefully that answers your question. I think that's what you're curious about. And there's even, like, you can take that steps further. Like my friend Darrell has a repository where he has 3 different modules for a single application. So like one model for presentation, one model for like the domain layer or interactors kind of stuff, if you're familiar with clean architecture, and one module for data. I think he calls them different things than that, but you can really, like, it's when you finally start to see what you can do with build variants and product flavors and Gradle and how you can sort of like separate the concerns of your app, it's pretty freaking cool. So anyways, yeah, hopefully that kind of answers your question, and I'm gonna move on. This is a less technical question, so I'm not going to spend a huge amount of time, but I'll just give some quick thoughts on it. The question is from Joshua. How to motivate yourself, motivate yourself to develop apps. Watching tutorials gets boring. So my answer to this, and this is the answer that I give a lot of the time, is when you're learning Android, if you don't have like a goalpost, such as like, let's say you have to do a demo project for a company, or you've got like tests or something, you've got like sort of those kinds of deadlines, it can be very hard to motivate yourself to keep developing and learning applications. Pardon me, especially if you're kind of just doing your own thing, which is something I have a lot of experience with. My main suggestion in terms of how to motivate yourself to sort of do self-directed studies is you have to have your own projects that you want to use and you are excited about. So for example, the first application I ever wrote was a workout log called Catalyft. And basically that application, I was working out a lot at the time. This was before I tore my back muscles up and all kinds of stuff, and I've been reduced to lifting like 20% of the weights I used to lift, and it's very depressing. But I was into working out at the time, so I said to myself, I'm going to build a workout logging app. So my main suggestion to you is pick a project which you probably would use and is something you would like to build. Now, if you're a beginner, you're going to want to only build basic features of the application. Don't try and build this giant apparatus, because unfortunately what I ran into is, as a beginner, you're going to make lots of structural mistakes with the application. So getting way too carried away oftentimes will just lead to you having to rebuild the thing from the ground up anyway. So my main suggestion to motivate yourself is pick projects which you want to build, like you are excited about, you can use, and beyond that I would have to talk about a lot more things to do with motivation that doesn't really belong in Android Q&A today, but I could maybe revisit that another time. But yeah, hopefully that kind of helps. Pick a project, learn things based on that project. Watch tutorials based on things that are directly relevant to what you need to learn for your given project, and that will help with motivation, and it will make it, it'll help the information retain, because instead of just like jotting down notes and trying to memorize all this crap, you'll have a project that you can think of and remember and be like, oh hey, so I applied MVP in this project. Now I understand how it works better. Hopefully that helps. What else have we got? We have got a whole bunch of Arabic, I believe, although I could be wrong. And I can't read Arabic, unfortunately, but if that is Arabic, marhaba. Wow, lots of questions. So this question is from Tina Fredericks. Tina asks, this is a good question. Okay. What are tried and true third-party, I'm just going to copy and paste the question, that's easier. What tried and true third-party libraries are essential for Android apps? So do I think RxJava is and will be industry standard? So this is a good sort of general question. So let's think about this. What are essential for Android apps? So there's sort of a couple main things I would look at, and these are the kind of libraries that pretty much any Android developer in any development company or app studio or whatever should sort of be able to bust out at any given time. So I'm kind of expanding on the question for beginners as well. But so like number one, you'll need a database library. I'll give you examples of what these are, but I just wanted to list out the things that I think are essential. You'll need a database library. You'll need a REST library. What else? Image loading library. And it really helps to have a concurrency library. Concurrency. Optional dependency injection library. So I'll just stick with that. I could probably list a few more things out, but that's sort of my main thoughts there. I'm just going to increase the font size a little bit for y'all. Let's do 30, not 3-30. There we go. Okay, so number one, let's talk about databases. So at the moment, there's basically only two database libraries or solutions that I would recommend. So number one is Room Persistence Library, which if you've been watching Google I/O 2017 and you've been keeping current with Android development, Room is the platform solution to databases now. So it's an SQL-based library. So you're going to want either, in this case, Room Persistence Library, which is part of Android architecture components. And if you're curious about Room Persistence Library, you're going to want to watch my giant long-ass video on it, because I literally build an entire application on camera with Room Database and Android architecture components, so go check that out. So that's the first thing. And then the other thing you might want to use is Realm, which is a NoSQL database, or an object, is it called an object-oriented database? I don't think so, but it stores things as objects. It's not an SQL library. And that one is spelled Realm. So you're either going to want, for databases, the only two I would suggest right now and for the foreseeable future are Room Persistence Library and Realm. They're both great solutions. I can't really tell you which one is better. I like them both. I've built apps with them both. They both provide RxJava support. They're both really frickin' good. So, to use a technical language, really frickin' good. Oh yeah. Anyways, so that's what I would say for database stuff. For REST library, I'm sorry, I can't talk today. For what REST, I'm not going to spend so much time on it, but you're either going to want Retrofit or you're going to want Volley. I've never actually used Volley, but I've anecdotally heard that it's a little bit faster than Retrofit, although I haven't really heard that Retrofit has any major issues with speed. And basically what these do is they allow you to sort of set up, actually I won't speak of Volley, but presumably it allows you to set up an interface to a REST endpoint. And Retrofit is awesome. It's integrated with RxJava. You can make asynchronous calls to a REST endpoint, a web app. You're either going to want to use Retrofit or Volley. I think most people use Retrofit, but Volley is the Android platform solution. You're going to want a good image loading library. And for that, at this point, I would recommend Glide. You can also use Picasso, but I think I recently played around with Glide, and I think it's a little bit better than Picasso at this point. I'm not sure if Picasso has still developed a whole bunch, but they're both good options. A concurrency library. So in this case, when I'm talking about concurrency, pretty much what I'm thinking of is where, let me pull up a graphic and that'll help. This is actually a graphic from my ebook. Where are you? Oh yeah. I think you guys are gonna like this one. So this is one of the graphics from my ebook. So what I would like you to think of is consider three-layer architecture. So we're thinking model view presenter, model view view model, model view controller. It doesn't matter. What I've done is I've chosen to say view logic data, which is not a real architecture. It's just me rejecting all those annoying names and saying at the end of the day, this is what the three layers do. There's a view layer, a logic layer, and a data layer, whether you call it view model or whatever. And so when an application executes, essentially what happens is if you've built it with a proper architecture, you're going to get like, and now I should say events don't always need to start in the view layer, but in the example of like a typical application, let's say I hit new workout on Catalyst, that sort of is an event which starts in the view, and then it goes to the logic layer, and then the data layer, and then the logic layer, and then the view. So essentially what happens is the user does some event, the logic figures out, oh, get some data. The data layer is either going to say have some data, or it's going to say I have no data, or it's going to throw an error. And then it's just going to return that result to the view. So hopefully that's pretty unambiguous here. And this just means over time this is what an event execution looks like. And how this relates to concurrency is when you're talking to especially the data layer and the logic layer, you're going to want to do that with some kind of library that helps you with concurrency. You can like use threads and handlers and stuff like that, sort of the home-baked Java stuff, but there's two different libraries that you can use instead. And so hopefully that was somewhat useful, that little digression there. But that's a sneak preview of the ebook. And that's definitely in the later chapters. So, so you're either going to want RxJava 2. I think RxJava 1 is still under development, but you're going to want RxJava 2 in my opinion. Or you're going to use live data, which is the Android architecture components solution. So which one should you use? And is RxJava still industry standard? I would say RxJava is most certainly still an industry standard. I haven't used live data enough to determine whether it's better, but it's also really good. And I actually had a pretty easy time building my Android architecture room application using live data. It's pretty easy to configure because it handles a lot of the concurrency. If you're not familiar with that word concurrency, it just means like events that happen in software normally execute line by line in the order that they're called, starting with the onCreate in Android or the main method in Java. And asynchronous events in code occur, you don't know when they're going to occur. So for example, if I send a request to a web app through REST, I don't necessarily know if that response is going to instantly come back. In fact, I should build my code such that it assumes it won't come back instantly. And so that's what concurrency is. It's dealing with things in your application which don't necessarily fire in a synchronous line-by-line order. And you can use either RxJava to deal with that, or you can use live data. I haven't used live data with retrofit and stuff like that, but I'm assuming you can configure that. And live data works very well. It plays very nicely with Room and View model from Android architecture components. So that's that. The last thing is a little bit optional, but I would say that it's worth looking into Dagger 2. The big thing about dependency injection is that, do you absolutely need it? No. Is it worth potentially 2 weeks to a month to figure out how to actually configure the damn thing? Yeah, I think so. What you can do with dependency injection is you can essentially pull all the code, with Dagger 2 and which is a dependency injection library, you can pull all of the code responsible for building stuff out of the rest of your app, and almost like create a separate layer of the application which just is responsible for building things appropriately. And if you configure it properly, you don't need to worry about messing around with creating singletons and having multiple database instances at the same time and stuff like that. So it is worth the investment, but Dagger 2 is fairly difficult to learn from the outset, I would say. Dependency injection is very simple, but figuring out how to set up subcomponents and all that kind of crap is a little more demanding, let's just say. Okay, I'm just going to run a quick commercial break, and we'll get to more questions in a moment. If you've liked the show so far, if you have liked the show so far, please do me a favor and hit the like button down below. Okay. So let's see here. Okay. This is an interesting question. So let me, I'm just gonna double check. All right. You know, I have so many questions. What should I pick? You know what? Okay. Let's do this one. This is from Josh again. This is a really great question. And then no more questions for Joshua because I've answered. This will be number 2. But this is an awesome question. So. Where is it? So Joshua is asking, what is RxJava in layman's terms? And this is, this is a good question. So what is RxJava in layman's terms? So this is going to be a fun one because I have to try and explain RxJava without jargon. So recall what I said a little bit ago about concurrency. So normally let's go to some code, and that'll be maybe a little bit easier to think about. So what I'll talk about is, let me discuss the 2 ways we can kind of communicate our between different layers. So the first thing, Joshua, is that I'm going to assume that you're comfortable with the idea of like a multi-layered architecture and having different classes with different responsibilities sort of communicating with each other. And again, if let me pull up that, where's that diagram again? So in this case, we've got view and logic and data. So this is sort of a generalized understanding, or a generalized idea of model view controller, model view presenter, model view view model, model view view model, model view view, whatever you want. And generally what I would say is that in most cases, the view and the logic are going to talk to each other synchronously. Hopefully you remember if you're not, well, I don't really have time, but synchronously just means like sort of instantly, just instant communication. Call a method, get a result. Whereas asynchronously means call a method, waiting, 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 an indeterminate amount of time, waiting, get the result. So that is synchronous and asynchronous. And in asynchronous code, the program does not need to, the program's execution isn't blocked. It isn't blocked from jumping lines. It's just line by line by line execution, whereas asynchronous can be like line by line asynchronous method, call, line, 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 call back, just like sort of randomly. Hopefully that makes sense. So pretty much what RxJava can help you do is, so when my fragment, which is the view, is talking to the presenter, it talks to it synchronously. So it just says presenter start, presenter stop. So it, you know, it's just immediate execution. I'm sorry, I've got to blow my nose again. Okay, sorry about that, folks. So, so think of that. That's synchronous. That obviously doesn't require RxJava. In my alarm list presenter, it's going to be talking to these use cases, and so basically, here is RxJava in a nutshell. So, if you'd like to look up a term, I would suggest you check out the observer pattern. As like a general research term. So basically what we're going to do is I kind of want you to pretend that the use case thing isn't a thing. I just want you to think of like my presenter is talking to a database, and let's ignore all the technical names and all the abstraction. So we've got view talking to presenter or logic. We've got presenter or logic talking to data, which is a database. So view and logic, there's instant communication. We don't need RxJava there. However, for the logic talking to the data, it might take an indeterminate amount of time for our database to call back to the presenter. So what RxJava does is it employs the observer pattern to have asynchronous communication. So I'm trying to think of how can I explain that well. In a nutshell, what I would say is how RxJava works is that, let's say normally I would want to ask the database for an alarm within POS-Trainer. Normally I'd want to ask it, I would suggest you open this repository because this will help you understand this. Normally I would ask it for an alarm object, which is just this thing here. The way that RxJava works is you essentially wrap an object in this thing called an observable. So if I go to the database, and I will explain these a little better in a moment, but if I go to the database, when I ask it for alarms, I basically get my alarms, a list of them out of the database, and then I wrap them in this flowable thing. Just pretend this says observable. Let's not talk about flowable versus observable. Just I wrap it in an object. And what that allows me to do is, think of it like this. So let's say I want you to imagine like we've got the view over here, we've got the logic, and then we've got the data. So the view asks the logic for a list of alarms, and how I think of it is the logic layer asks the data layer for its alarms, and it sort of sets up this stream. and this observable thing kind of flows down the stream. This is an observable. And then what the data layer is going to do is it's going to like create this thing. It's going to like create a list of alarms in here. And then when it's done, this sort of object is going to flow back to the logic layer. How's that for a layman's explanation? And then depending on what it looks like, it's either going to call on next, on error, or on complete. So essentially what I'm saying here is RxJava is a way for different parts of your application to communicate, and it allows you to change the flow of data and logic of your application over time based on events. It's really hard to explain simply, but hopefully that makes sense. Essentially what you're able to do, and this is why RxJava is so amazing, or asynchronous reactive libraries are so amazing, is your application can change over time. So the last thing I'll do is let me pull up one more diagram, and where is it? And this might also help a little bit. And this will actually talk about live data, which is a different sort of reactive sort of library. So what I have here is the software architecture diagram for my room database tutorial. And in it we have model view, view model architecture. I really hate that name, but that's fine. And without getting overly technical, I want you to think this is the data layer, this is kind of the logic layer, and this is the view layer. Now, normally what would happen is we would have our, in model view presenter, let's say, I would have my fragment, where is it? Oh, that's totally the wrong. Normally, in model view presenter or model view controller, my presenter would be talking to the view as so. It would have a reference to the view. And my view would have reference to the fragment, which it does. The way that model view view model works is a little different. Instead of, so we do have the view talking to the view model and able to ask it able to, how does that work? Yeah, able to send calls to the view model. But the view model does not depend on the fragment. So if I open up this project, this is the project I'm talking about, and I go to the view model, somewhere, where are they? If I go to a view model, there's no view that it calls back to. It does not reference the view. It does not have an arrow pointing up. Instead, it points to this live data object. And then the view observes the live data object. So that kind of looks like, so as you can see here, there's no reference to the view model. The view model just asks the room database to get the data that it needs, get list items. And then in the fragment, it observes, it creates almost an observable of the data that it needs. And so when that data sort of executes, when the database finally returns the data, instead of the view model telling the view, hey, the data is here, the view model is constantly watching. It's observing the data, and it gets notified of changes. So I've tried to explain in a couple different ways how reactive libraries work. So whereas in most cases you have different parts of the app just talking to each other and directly asking each other for things, with observables you create an observable, you pass it into a different part of the app, this object gets full of data, and then it kind of gets passed back, and then the other part of the app, when it receives it, is like, oh, okay, I should probably draw this data. So hopefully that answers your question somewhat. That is a layman's explanation of reactive extensions in RxJava. My best attempt at it today. Anyways, let's see. Let's do one more question because I'm out of tissue paper here. So once my nose starts running again, that's going to be that. What else have we got here? Hey, what's up? Good to see you again, Darrell, and we got Bassam and Sohail. Thank you for joining me, everyone. You know, Darrell, I would answer your question. How do I handle threading in use cases, and if so, why? But I think you do that better than I do right now, so I need to learn some things from you. I'm going to be working on Pos Trainer again a little bit and upgrading my clean architecture implementation because it needs some work. Let's see here. Hello from Russia. Привет. Sorry, I'm trying to find a different question here. You know, what I'm going to do is, okay, I saw one on naming conventions. That's a pretty easy one. Okay, that's a good general question that I can answer, and then that'll be the last one. And that's an interesting name. Not sure if that's Eastern European or Baltic or perhaps Turkish. I'm usually pretty good at guessing names. Okay. So this is from, I can't write it properly, but and I have no idea how to pronounce your name, unfortunately, but Vaclav asks, I'll just copy and paste it in. So this would be the question I end on. I would get to one of the more technical ones, but you know, a lot of times I end up rambling for 20 minutes and my nose is already starting to run again. So, do I have any tips for naming conventions in Android projects? Boy, do I ever. So I'm going to explore this from two perspectives. So the first perspective will be naming conventions for your sort of architecture and package structure. And then the other one I'll look at is naming conventions for methods, classes, and layouts, and I'm going to try and do this pretty quickly. So what are my tips for naming conventions? Let's start with package structure. So, number one, your package structure should help people, including you, understand what your project is and what its components are. So that's number one. So if I open up, let's do this through the browser because then I can actually zoom in. Let's go to Pos Trainer. All right. So I've got Pos Trainer open in GitHub, and the link is just down below. So the first thing is your package structure should help sort of explain what your project is and where everything sort of needs to be. So the first thing is when you're designing the package structure, you're basically gonna have to assume that whoever's watching this understands like what a basic app architecture is. So that's the first thing. So for example, let's just kind of go through this really quickly and see if this makes sense. So we've got these different things. We've got alarm detail, alarm list, alarm receiver, and settings. So are those fairly descriptive names? Like if I open up alarm detail, let's do this with the app itself. When I open up POS Trainer, this is alarm list. Displays a list of alarms. Sorry, I just got a text message as I was doing that, and it sidetracked me. So that's alarm list. If I edit an alarm, we've got alarm detail. If I fire an alarm, alarm receiver shows up. If I go to settings, actually, I'm not even sure if I've implemented. Yeah, I've implemented settings, but I can click on that. So basically, every component of my app has a name, a descriptive, simple name that just says what it is. It's not a stupid, long, technical name. It's just a simple alarm detail, alarm list, alarm receiver. Alarm detail shows a detailed view of the alarm. Alarm list shows a list of alarms. Alarm receiver receives an alarm. So for packages and for features, name them smart things like that. Don't get overly technical. Don't have obscure names. And then when you're working with other people, you're just going to have to assume that they're familiar with the architecture of the app and put a layer for each, or sorry, put a package for each. Name each layer appropriately. So use cases are fully use cases. Data is all the data stuff of the application. So that's sort of my tips for naming conventions of the whole project is structure it like that. Give it reasonable names that say what the thing is so that when someone reading this, assuming they have a basic understanding of clean architecture, then they're going to be like, okay, this is where the use cases are. That's the data. These are features. Pretty straightforward. So that's the package side of naming tips. So the next thing is, let's go here. So number one. Number two. I guess I would say name. Essentially, what I would say for that part is, apply the same principles to your class names. So, like, I've got the. I showed you the different parts of this app. Now, if I open up alarm list, for example, I've got alarm list activity, alarm list fragment. I don't think I need to go over that much more. I think you get the gist there. Like, name things appropriate to what they do. So that's that. I'm not really going to go over that, but that's sort of naming conventions for classes. But let's talk about find a consistent naming. Let's say follow consistent naming conventions for your XML. So that would be number two. So if I open up my XML, I always name things basically the same in the same format. Now you don't have to follow my format, but for example, an image button always begins with IMB. And then I'll give it like, usually I'll follow it with the feature, so alarm detail. And then I'll give like the final descriptor of what the thing is. So then in this case, this is a back button. Whoa. Can't answer that right now. Sorry, phone was ringing. So yeah, so for me, I always call image buttons IMB. I always call edittext EDT. I call labels, or sorry, text views as just LBL. I do like generally a 3-letter abbreviation. You don't have to do what I do, but be consistent with your naming conventions. Why is that? Fuck off, you fucking phone. Sorry. why should you have consistent naming conventions? Well, when you're working on a big project and you can't remember the name of every view when you're calling like find view by ID, that way if I know I need to like, here's a better example. Let me just like delete this, and let's say I was creating this variable, I was binding this for the first time. I would say find view v.findView by ID, r.id, and then I'm like, oh crap, what is it? Okay, it's a text view. So I know that I always call my text views starting with LBL. And then this is in the alarm list fragment, so we'll go alarm. And then sometimes I'll do the second prefix, alarm list, but in this case I just see, oh, okay, alarm, LBL alarm prompt. So what I'm trying to demonstrate there is that my naming conventions help me write code. If you follow a consistent naming convention in your XML, you don't have to remember what the things are. You just start typing them out and the autocomplete helps you. Not to mention it's easier to read. So that would be my second tip, is follow consistent naming conventions. Set up a scheme for your XML. And yeah, let's just fix that up before I go. And that's, basically it. I would say the same thing for methods, but I'm basically repeating myself at this point. But like, name your methods intelligently. So for example, make toast makes a toast, show and undo snack bar shows an undo snack bar, insert alarm at. All of my methods basically say exactly what they do. And in the event that I have very large methods, I'll even create helper methods to sort of make them make even more sense. So like one example is if I open up alarm list presenter, I could like hypothetically stick all of, where is it? I could like hypothetically stick all of this crap in one area. Like I could sort of nest RxJava code down in here, or some stupid shit like that. But what I'd rather do is create these helper methods. So when onComplete is fired here, then it's going to call alarm on alarm set, for example. And then I've created a helper method. So instead of having one method that toggles alarms and sets them and cancels them potentially, I have helper methods which do one thing that I can call instead. And so what that does is it essentially helps your methods. It improves the legibility of your code because methods don't have long, obscure, annoying names. So again, create smart and simple method names and don't be afraid of creating helper methods. And helper methods are just like sub-methods that you can call so that you don't have one method doing 3 different things. So that's basically it for now. That was a fun episode. So what I'm going to do is I'm going to be... Oh yeah, I hate Hungarian notation. So yeah, that's basically it. Thank you so much for watching. I will be live again for next stream on Sunday, which will start at the same time, and hopefully my nose will be unplugged by then. And yeah, I'm gonna have an update coming out for my channel about sort of what kind of content I'm gonna be doing for the rest of the year. So watch out for that if you are curious. And beyond that, I hope you just have a good day or evening or night. And thank you for watching. Watch out for my Android ebook. It'll be out soon. Peace.